Hello students, after completing the topic of components of linear velocity and acceleration in the plane polar coordinates, we'll solve some problem where we'll try to find out the value of velocity v and acceleration, okay, with these coordinates. So the problem is a particle moves along a curve x is equal to 2t square, y is equal to t square minus 4t, and z is equal to 3t minus 5, where t is time obviously. Find the components of its velocity and acceleration, at t is equal to 1 second in direction of I minus 3j plus 2k. Correct? So this is the question given to you. So how will we write this question? As we'll write first phi, which is displacement. Correct? So last time we had seen the definition as such. We said which is xi plus yj plus zk. Correct? I, j, k are obviously my unit vectors. Equation number 1. Correct? So put the value of x, y, z, what is given in the question, which will make the equation 2t square I plus t square minus 4t times j plus 3t minus 5 times k, equation number 2. Then to get a velocity, if phi is displacement, what is velocity? d phi by dt. Correct? So to get d phi by dt, what I'll have to do? Put the value of phi, which is 2t square I plus t square minus 4t times j plus 3t minus 5 times k. Bracket complete. If at all you take differentiation, what you'll get over here? 2 into t square will be 2t. So this is 4t I, correct, plus t square will be 2t minus 4 times j, and for this thing it will be plus 3k. D by dt of 3t will be 3. So 3k, this is my equation number 3. So I am ready with my velocity. Correct? Now what I want at t is equal to 1 second. So what will I say? Velocity at t is equal to 1 second will be 4 into 1 times I plus 2 into bracket 1 minus 4 times j plus 3k as such. So it should be 4i because t is 1. Now over here this is 2 minus 4, so will be minus 2j plus 3k. This is my value of velocity at t is equal to 1. So this is my first answer, equation number 4. Okay. Now I'll have to go to component of velocity in the direction of the given vector. So next is component. What is asked? Find the component of velocity in direction of which vector it is given to you? Is I minus 3j plus 2k. This is vector given to you. So what is the formula to find component of velocity? Write the vector I minus 3j plus 2k divided by its modulus dot of the given vector. What is the answer? What you got? Which is 4i minus 2j plus 3k. Correct? This is divided by its magnitude. So I will be 1 square plus this is minus I minus 3 will be square hai to plus 3 and this will be 2 square. So I minus 3j plus 2k divided by this is 1 plus 9 10 plus 4 14. So under root 14 dot 4i minus 2j plus 3k. Correct? So simplify. I dot I, j dot j, k dot k term will exist. Remaining term will get cancelled. Correct? By which I'll get the answer. 1 into 4 will be 4. Minus 3 into minus 2 will be 3 2s are 6. And 2 3s are 6. So I will have 6 plus 6 16, 12 plus 4 16 divided by under root 14. This is the component of velocity. I got the answer as equation number 5. Correct? Next I have to do is acceleration. Now what is acceleration formula? dv by dt. I am ready with my velocity. Correct? So to get dv by dt, what will I do? I will write the value of velocity, what answer I got over here. Equation number this one 4ti, equation number 3. Correct? So I'll write 4ti plus 2t minus 4 times j. Correct? Then plus 3k. This is the value what I have got in case of velocity is concerned. Correct? So now simplify this. 4ti. So it should be 4i. d by dt of 4t should be 4. Over here it will be 2. 2t will be 2. Here there is no term. So 4i plus 2j is the only answer. What is the next? This is my equation number 6 and 7. Now what I want? I want component. Correct? So component in of acceleration. Correct? In direction of which vector? It is I minus 3j plus 2k. What is what I wrote earlier? Same logic I'll use it. So I minus 3j plus 2k divided by under root 14. Same logic. 1 square plus 3 square plus 2 square dot 4i plus 2j. Correct? So if you simplify this, I dot I will be 4. Correct? J dot j 3 2s are 6 divided by under root 14. So it will be minus 2 by under root 14 is the answer for the acceleration, component of acceleration in the direction of given vector. That's what we got. So this is a almost 3-mark question to find out the value of component of its velocity and acceleration at t is equal to 1 second in direction of the given vector. That's what is the question. Right? Next we'll go to very important topic again. So which will take it as over here partial derivatives of vectors. Correct? Now over here, suppose we say v is my vector. V is a vector which depend on scalar independent variables x, y and z. These are my scalars. So how do you say daba v by daba x? How will you define this? We'll say limit delta x tends to 0 v of x plus delta x y comma z, which means only x has changed to x plus delta x, y and z remain constant. Correct? Divided by delta x. This is called as daba v by daba x. Same way I can write daba v by daba y also. That time what I'll have to write? Delta y tends to 0. Correct? Then what you'll do? you'll keep x and z constant, but that time you will change y. Minus v xyz divided by delta y. And similarly, delta v by delta z should be how much? V xy constant now, and make z plus delta z minus v xyz divided by delta z. Correct? So this is the individual formula. This is only depending on x, y and z. But when we say all these x, y, z change simultaneously, correct? That time what we say? Then we say total differential. If x, y, z change simultaneously, then the total differential of v, this v, will be dv is equal to dabba v by dabba x dx plus dabba v by dabba y dy plus dabba v by dabba z dz. This is my formula when all x, y, z change simultaneously. Correct? And higher order derivatives, how will you write? We'll write it as dabba square v. This is dabba v by dabba x. First one, first order. We want to go higher. Dabba square v by dabba x square. Correct? Similarly, dabba square v by dabba y square, like this. Or dabba square v by dabba z square, and so on. These are my higher order derivatives. Correct? Next, now we'll define a very important term called as del, which is called as vector differential operator. Very important concept in physics. Right? Now, to define this, what will I have to define first? We'll have to say, consider, suppose we have a region bounded by a scalar field phi. Correct? And what is phi? Phi is basically a function of x, y and z. We'll call equation number 1. Correct? Then, now phi being a point function, we can write in terms of phi is equal to phi of r. What is r? R is already I discussed in the last topic, which is xi plus yj plus zk. This is my r. Correct? Now, if dx, dy, dz, are the infinitesimal, which means very small, infinitesimal increments in x, y and z at the same time, then the total differential of this phi, which is d phi, it is dabba phi by dabba x dx. Like this I wrote total differential of v, because that time my v was the function. Now I am talking about phi, so d phi. So here I had dv, here I had d phi. Here my phi is scalar. This was my vector. So dabba phi by dabba x dx plus dabba phi by dabba y dy plus dabba phi by dabba z dz, equation number 2. Correct? Now, how we can write the RHS, that matters now. So, how will I write? I will write I dabba phi by dabba x plus j dabba phi by dabba y and k dabba phi by dabba z dot, correct, dot I dx plus j dy plus k dz. Correct? Now what I used over here? The identity of what is called as I dot I, j dot j and k dot k. Correct? So this I can write as, this I can write in a fashion which is I dabba by dabba x plus j dabba by dabba y plus k dabba by dabba z in one bracket dot dr outside the bracket phi. Correct? So what I'm doing now, I'm writing in such a fashion this I'll call equation number 3. I took the phi out, so I double phi by dx, and this I'm writing dr because r is xi plus yj plus zk, so dr should be correct. Dr should be I dx plus j dy plus k dx. That's what I wrote here. And in this term, I took the phi out. So this is I double by double x, j double by double y, k double by double z. Correct? This is my equation number 4. Now, what I need to write over here? Now, this del is basically this term. So we can say, therefore, del is equal to I double by double x plus k this is called as the del, or it is called as vector differential operator. This del I double by double x plus j double by double y plus k double by double z is called as del or vector differential operator. Correct? Now, in this, suppose phi we always say is a scalar, correct? And v we say is a vector. And now we are ready with our del, which is my operator, correct? Vector differential operator. Now suppose we say del operator operating on phi, correct? A vector differential operator, what we have just defined, vector differential operator is operating on a scalar, is basically called as gradient phi or grad phi. Then the vector differential operator operating with dot product with the vector v, it is called as divergence. And vector differential operator cross product with the given vector v, it is called as curl of the vector. So divergence of vector v and curl of vector v. So these three things we have to discuss now onwards. Correct? So before that, we'll do one more thing, which is called as del phi. Now what is del? Vector differential operator. What is the definition? I double by double x plus j double by double y plus k double by double z. I just said over here, I double by double x, j double by double y, k double by double z is called as del, vector differential operator. Now what we have to write outside the bracket phi, correct? So if we write it this way, I double phi by double x, take it inside, plus j double phi by double y plus k double phi by double z, correct? This term we are ready with. Now dot product of del phi with del, correct? Dot product we want to discuss now. So del dot vector differential operator del dot del phi. What I did, this dot del phi. Del phi I am ready with. So put the value. First put the value of differential operator. What is the value? I double by double x plus j, double by double y plus k double by double z. I am ready with del dot. This term, what I just discussed, correct? So I'll say I double phi by double x plus j double phi by double y plus k double phi by double z, correct? Now do I dot I. I dot I is 1, j dot j is 1, k dot k is 1. So what will I get? I'll get del square phi by del x square, correct? Plus del square phi by del y square plus del square phi by del z square, correct? So if I take phi out now, so what will I get? del by del x square plus del by del y square plus del square by del z square times phi. Correct? So this term is called as del square. Earlier we just defined vector differential operator del. This one. Correct? Now I did defined del square. So what is del square basically? Del square is daba square by daba x square plus daba square by daba y square plus daba square by daba z square. This is called as my Laplacian operator. Laplacian operator. Correct? This is very, very important. Now I'll call this to be my equation number. This was equation number 4. Correct? Then I'll say this is 5 and this is 6. Correct? Now the next one. Next is we'll just define what is called as gradient of a scalar del phi. That is the first part. Gradient of a scalar phi, which is called as either this. Correct? So how will we write this now? Suppose we write d phi. What is d phi? Which is grad phi dot dr. Correct? So earlier we wrote this equation. I double phi double x plus j double phi by double y plus k double phi by double z dot I dx plus j dy plus k dz. This I have to write again. This is my grad phi. Correct? This is my grad phi and this is my dr. So I'll write the same term over here again, which is the definition of grad phi. So I'll write I double phi by double x plus j double phi by double y I j k dot I dx plus j dy plus k dz. This is my grad phi. Correct? So now we'll just define the physical significance of grad phi. Correct? For that, I'll just draw the simple figure. This is one part called as S2, and here I have S1, and in the exactly in the middle I have to draw. Okay, and here I'll show my S1. Correct? Now my job is to join from this point over here. So draw like this. And take one point outside and try to join it there. Join this also. Correct. Now this is part is called as phi. This is called as phi plus d phi. This is r. Correct? This point is p. Correct? This point is q. This point is r. This is my o. Correct? This is r plus dr. And this is theta. And this is my unit vector n cap. Okay. Now I'll just explain the diagram to you, and then we'll do the revision in the next video. So over here, what's happening? Here we have considered two surfaces. These two surfaces, S1 and S2. Now S1 and S2 looks little at a farther distance, but they are actually very close to each other. To explain it, I made it this way. They are actually very close to each other. Now scalar function has value phi for S1 and phi plus d phi for S2. Correct? Now what we have taken? We have taken O as the origin. Correct? So my phi function will be what? Phi will be function of x, y, z. Correct? Now consider the point P and Q. What I took first, P point and Q point. P point on the surface S1, Q point on the surface S2. During the movement from point P to point Q, from S1 to S2, what's happening? The scalar function changing from phi to phi plus d phi. Correct? So therefore, the total differential d phi, the total differential d phi is dabba phi by dabba x dx plus dabba phi by dabba y dy plus dabba phi by dabba z dz, equation number 1. Correct? Now OP, how much is my OP? OP I mentioned R. Look at this. Correct? OQ is how much? O to Q is R plus dr. And how much is PQ? PQ we said it is dr. It has to be dr, obviously. This is R plus dr, so this has to be dr. Correct? So we have got all this. So therefore my dr vector will be dxi plus dyj plus dzk. Obviously r is ix plus jy plus kz. dr should be idx plus jdy plus kdz. Obvious. Okay? Equation number 2. So therefore equation number 1, how can we write in taking into account this also? We can write d phi is equal to dabba phi by dabba xi plus dabba phi by dabba times y plus dabba phi by dabba z times k dot this value dxi plus dyj plus dzk. Correct? And what is this bracketed term? Already we wrote this. Correct? So prior equation also I wrote this term. That is my grad phi. And this is my dr. Correct? We wrote this term earlier also. Grad phi. I dabba phi by dabba x, j dabba phi by dabba y, k dabba phi by dabba z, which is over here. Writing I here or here doesn't make any difference. I dx, j dy, k dz. Here I wrote dx, I dy, c. No problem. Any way you can write, but still you get gradient of scalar phi is grad phi dot dr. Correct? This is my equation number 3. Equation number 3. Now, suppose we write d phi is del phi, that is grad phi, the definition, dot dr. Del phi dot dr, equation number 4. Now we showed one more vector called as n cap. What is n cap basically? N cap is a unit vector normal to the level surface S1. I took just straight vector over here, normal to S1 at point P. Correct? This unit vector is in direction in which phi is increasing, because this was phi, but this is phi plus d phi. Correct? So what will I get? I will get angle theta. Where is angle theta? Angle theta is over here. So now if phi is the angle, if theta is the angle between PQ and N, correct? Then what we are going to do? We are trying to find out the value of exactly that vector. So that will be over here. I will try and write. If theta is the angle between PQ and N, then d theta is equal to del phi dr cos theta, because this is dot product, correct? So d theta by dr, take dr down, will be del phi cos theta, correct? So when theta is 0, everybody knows cos 0 is 1, correct? That time I'll get d theta by dr will be maximum, which is, so what we can say in short, d theta by dr will be maximum, which is del phi, which is del. So magnitude of this del phi is maximum space rate of change of phi at a point, correct? And is directed along the normal over here, normal to the level surface. Phi is equal to constant through the point. That's what is the meaning of what is called as d theta by dr to be maximum, which is called as del phi, correct? So next lecture I'll try and solve a problem on directional derivative, correct? Thank you. Okay, so please watch. Anything not clear, feel free to ask.